We're going to talk about what are called complex fractions for lesson 55. And to start, you can see that, well, in the topic complex fractions, we have the word fractions. And we know what a fraction is, but what is a complex? And that's what I want to go over in this first slide, is what in the world is a complex fraction. Now, if I had, say, something like this, if I had a fraction, a over b, a fraction is simply a numerator and a denominator, right? The top number being the numerator and the bottom number being the denominator. So the top is the numerator, bottom's the denominator. Now, what's a complex fraction? Well, a complex fraction is where you have not only one fraction, but you have a few fractions. So notice I'm going to add something to the a over b. I'm going to add c over d. Now what I have is I have a fraction on the top, I have the fraction on the bottom, but really this whole thing is a fraction. You could look at, this being the numerator above this main bar, and then this value would be in the denominator below the main bar. So really a complex fraction, its name is appropriate because complex means pretty involved or maybe difficult. I don't like using the word difficult because these aren't difficult, as you'll soon see, but they're just involved. There's a lot of stuff going on, and you can see that that's happening in this example. So a fraction is just it's a number of fractions. Now, before we get into this, there's a couple methods I'm going to show with simplifying complex fractions, and you're going to have to pick out the one that you're most comfortable with. Now, one of the methods is actually reviewing dividing fractions. So let's review dividing fractions. If I had 2/3 divided by, say, 1/7. Okay, how do you divide fractions? Well, you take the first fraction and you leave it as it is, and you change the division symbol to multiplication. But in doing so, what do you have to do with the second fraction? Well, you got to flip it. You got to take the reciprocal of it. So actually, to divide fractions, we actually multiply them. We multiply the first fraction by the reciprocal of the second one. So then I can look at it, and since it's multiplication, is there any cross canceling that I can do? With a 7 and the 3, is there anything I can cancel out? No. How about the 2 and the 1? No. So then you multiply across, and you get 14/3, or you could change that to a mixed number, and that would be 4 2/3. And that's a quick review of dividing fractions. All right, let's take a look at example 1. Now this is really what this section's all about, is simplifying complex fractions. Now in example 1, notice I have 1 over r, and then what I'm going to do here is I'm going to highlight this main bar. Okay, that's what I refer to as the main bar, because when you have examples like this bar will be maybe a little longer, it'll be a little thicker. And what I have here is I have a fraction over a fraction, right? I have a fraction 1 over r in the top and 1 over z in the bottom. Now, I'm going to show you two ways to do this. One way is you can just simply think of that main bar, that red bar, as a division symbol. So really, this problem really means this: 1 over r, that fraction, divided by 1 over z. That's what the problem really is, with this main bar, the red bar, being the division symbol, all right? So now how do you divide fractions? Well, remember what I said previously. You take the first fraction, you change the division to multiplication, and then you flip the second fraction. So or take the reciprocal of 1 over z, which is z over 1. Now there's nothing I can cross cancel, right? So I multiply across. 1 times z is z, and r times 1 is r, and you're done. That's it. Okay, you've simplified this complex fraction. Now, in a different color, I'm going to show you another method. Now, really, this other method is probably a little less time-consuming, but it might be a little more unfamiliar, but I don't think so. So, give it a chance. All right, what we're going to do here is we're simply going to take the bottom fraction, 1 over z, and I'm going to take the reciprocal of it. So I'm going to multiply the bottom by its reciprocal. So flip the bottom fraction. But in doing so, remember the magic, the golden rule in algebra. What you do to one, you got to do it to the other. So if I multiply the bottom by z over 1, I have to multiply the top by z over 1. Now, why did I multiply the bottom by z over 1, or the reciprocal of the bottom? Well, I did that because my z's cancel, and then my 1's cancel out, and all that's left in the bottom, z divided by z is really 1, so I have left in the bottom is 1, or nothing. Now on the top, I can't cross cancel anything, but notice what I have in the top, 1 over r times z over 1, and that's what I had in the other method, right? Multiply across, and you get z over r. You get the same answer. All right, let's do another example. Let's take example 2. And this time it's a little different, but not a lot. In the top I have a fraction, right? X over m. Now on the bottom, do I have a fraction? Well, you might say no. All I have is d, but really we could write that as d over 1. I do have a fraction. All right, so in red, I'm going to do the first method that I did in the other. So I'm going to think of this division bar. I'm going to think of the division bar, the main bar, okay, as a division symbol. So I have x over m divided by d over 1. Now I'm going to change it to multiplication. So to divide fractions, we multiply by the reciprocal of the second fraction. Check if I can cross cancel. I can't. All right, so there's nothing to cross cancel, so I multiply across. So x over md, because x times 1 is x and m times d is md. And that's it. Now in blue, I'm going to go through it the other way. And again, give this a chance, because actually it's something that's going to make things in the future a little easier. So I'm going to multiply the top and the bottom by the reciprocal of the bottom fraction. So the reciprocal of d over 1 is 1 over d. And what I do to one, I got to do to the other. Let's see, the d's cancel, the 1's cancel. Nothing's left in the bottom. In the top, nothing to cross cancel, so multiply across, and I get x over md. And that's the second method of simplifying complex fractions. All right, another similar example. I'm going to go through this a little faster. So you have n over a divided by b over d. Change it to multiplication, n over a times d over b. Remember, you got to flip the second fraction. Anything to cross cancel? No, so I multiply across, and I get this. Now if I use the second method, I'm going to rewrite this. If I use the second method, and here's my main bar, I'm going to make that a little thicker. All right, I'm going to multiply the bottom by its reciprocal. In doing so, I get everything to cancel out. That's why I did that. But in the top, I got to multiply by the reciprocal of the bottom, right? If I multiply the top or the bottom by d over b, I got to multiply the top by d over b. Now nothing to cross cancel, so I get nd over ab. All right, last example. In the top, do I have a fraction? Well, yeah, I kind of do. I'm going to write w as w over 1. It's a fraction now. All right, so really I've got a fraction in the top and I got a fraction in the bottom. Now my fraction in the bottom is a little different, isn't it? I actually have a couple in the bottom there, w plus c, right? Well, same process. Think of this as w over 1 divided by, because remember this main division bar means a division symbol, divided by 1 over w plus c. All right, now change it to multiplication. W over 1 times, flip them, w plus c is now on the top over 1. Now, nothing to cross cancel, so I multiply. So what's my answer? Well, it's whatever w times w plus c is. And notice I have the w plus c in parentheses because it's a couple, so I distribute and I get w squared plus wc. Now if I use the second method, and I think to save a little writing here, I'm just going to erase what I have for the first method. So if I'm going to use the second method, I'm going to multiply the bottom and the top by the reciprocal of the bottom. All right. So what's the reciprocal of 1 over W plus C. Well, I'm going to multiply the bottom times its reciprocal, so I flip them, but I also got to do that in the top, like so. Now, this couple and this couple cancel out, right? Not just the W's cancel out, not just the C's cancel out, but the whole value, that whole thing cancels. Now on the top, nothing to cross cancel, but I got to take W times whatever times the couple, right? Which is W squared plus WC. All right, so what I have then, or what we've gone through, is what are complex fractions and how do you simplify complex fractions?